Okay, before we talk about graphs and our next topic on graphs, I want to take a second and talk about symmetry. So what you see right now is a drawing by an artist named M.C. Escher, who you may have heard of, may not have. You see images of his around. A lot of them are sort of optical illusions, but he was a mathematician as well as an artist, and he did a lot of um, drawings that are like this, which is called a tessellation. So it's different images, like you use the same image over and over to fill the plane. And as you can see, these are crabs that all fit together, and it's a symmetrical image, and it's a specific type of symmetry. So you probably talked about symmetry in geometry, and if you remember, this is what we call reflectional symmetry. It has reflectional symmetry among others. There's also some rotation and some glide rotation. But we do have this situation where if you draw a line right down the middle, um, this half that we're seeing right now is the same as that other half, right? It's a mirror image. That if you were to just put a mirror right down the middle of this, you would end up with the same effect. So this is one example of reflectional symmetry from Escher. Here's another one. I'm going to turn it sideways so we get the line right down the middle. We have a line of reflectional symmetry right down the middle of these butterflies, right? We have another one, a line right here where if you put a mirror, you've got the same mirror image on each side of it. So this is reflectional symmetry. And a lot of times when you talk about things being symmetric, that's the type of symmetry that you're talking about. However, there's a couple of other types of symmetry, mathematically speaking. One is rotational symmetry. So this is another Escher drawing that shows there's no line where if you draw a line down the middle and put a mirror, it's going to be the same. But you notice that if you take this point right here where the fish's tails meet and you turn it, right, you rotate it, this fish rotates onto this fish rotates onto this fish, like that. So if you were to just turn it 90 degrees or 180 degrees, you would get the same image. Similarly, we have um, these lizards that have rotational symmetry. You can pick a point right here, and you have this 180-degree symmetry where this would rotate right onto this little lizard. So these are a few examples of reflectional and rotational symmetry. And we're going to use that to talk about different types of graphs. So coming back to math images or graphs, we have right here a parabola, a graph of a parabola. Specifically, well, I don't even get into what it is, but we have a quadratic, the graph of a quadratic equation or a parabola, and this is showing how we have y-axis symmetry, where if you draw a line down the middle here, if you had a mirror on the y-axis, these two sides are the same. You just kind of flip it over, right? Whereas rotational symmetry in a graph looks more like this, which is f of x equals x cubed or y equals x cubed. And here you notice it's kind of like our like our lizards, where if you rotate it around, you get rotational symmetry instead of reflectional symmetry. So two different types of symmetry: rotational symmetry, which we call origin symmetry when we're talking mathematically, or talking algebraically, I should say. And we have y-axis symmetry, which is that reflection across the y